Welcome back. We're looking now at section 6.3 in factoring. In this section, the type of trinomials we're looking to factor are going to be able to form ax squared plus bx plus c. And in this section specifically, it likes to consider values for a where the coefficient of a is not equal to 1. These types of problems where the a is not equal to 1, and we cannot factor out a greatest common factor to get the value of the a coefficient equal to 1, these problems require a special modification done to the procedure that we did before. It is going to bring in another technique that we covered in section 6.1 known as factoring by grouping. So if you're kind of picking through the techniques for factoring and some of this looks unfamiliar to you as you look at the first problem, please don't try to go on and pick this up. You really need to go back to the techniques that were covered in 6.1 with learning about factoring out the greatest common factor, and then the work with factoring by grouping that is shown in the later videos for reviewing section 6.1. So this work gets pretty complicated, and 6.3 in terms of the single type of factoring is probably about as challenging as it gets. There will be types of factoring later which will incorporate multiple levels of factoring within a single trinomial or polynomial or even a binomial. But for one type of factoring involved in a question, this type of factoring is probably seen by students as typically the most challenging. So let's go ahead and let's see how all of this ties together. We're going to first look at question 9. So the problem in section 6.3, question 9, is 2x squared plus 7x minus 4. So what we're going to do in this question is first, again, identify the values of a, b, and c. But I'm going to do this a little further away, and this will be explained here in a little bit. So I'm kind of giving this problem some room to breathe, because this is going to involve more work than the previous trinomials we factored in section 6.2. So the value of a is equal to 2, the value of b is equal to 7, and the value of c is equal to negative 4. So we're going to take these coefficients that we found, and we're going to put them into our x box again. But here, where I always talked about using a times c before, and where some of you may have gotten into the habit of just putting the value of c in, now the value of a is important. Because since we have a value of a that's not equal to 1, we need to multiply the values of a and c together. So that's going to be 2 times negative 4. So we're looking at a value here of negative 8. The value of b is still going to be this value in the v in the center, which is going to be 7. So just like we did before, we're looking for two values of two numbers that multiply to a negative 8, but that add to a 7. So the techniques we learned in section 6.2 are going to continue to help us here, but we are going to take the section 6.2, combine it with what we learned about factoring by grouping in section 6.1, and put these two things together. Well, the only two ways, or the only way we can multiply two numbers to get a product of negative 8 and a sum of positive 7 is to multiply positive 8 times negative 1. Because the a coefficient is not equal to 1, we cannot simply put these in binomials anymore. We need to use these two numbers for something different in this process now. So again, let me say this because this is a really key idea. Because the a coefficient is not equal to 1, we need to do something different with these pair of numbers. So what I'm going to do with these pair of numbers is the following. I'm going to take this middle term, plus 7x. I'm going to take the middle term and I'm going to rewrite it a little bit. And what I'm going to do, instead of leaving it as positive 7x, I'm going to go ahead and write it as the sum of two terms. I'm going to use the two numbers here for the purpose of doing that. So what I'm going to do is take 7x and I'm going to write it as negative 1x plus 8x. So most people should feel comfortable knowing that negative 1x plus 8x is going to be plus 7x. I get the negative 1 from here, and I get the positive 8 from here. This will work because, remember, we get these two numbers by having them add to the 7 that we have in this. Now, after I rewrite positive 7x as negative 1x and plus 8x, I bring down my other two parts of the trinomial. So now I have a polynomial of 4 terms reading 2x squared minus 1x plus 8x minus 4. So now I have 4 terms in the polynomial, and now I'm going to apply factoring by grouping to get my binomial factors. So as we showed in the end of 6.1, I'm going to split these up into 2 parts and give them a little breathing room to separate them. So this would be 2x squared minus, and I don't have to write minus 1x, I'll just write minus x. And over here I'm going to write plus 8x minus 4. Some of you may be wondering, does it matter where I put the negative 1 and where I put the 8? You will still get the same answer, but the factoring may be easier or more difficult depending on your factoring skills. So I put the negative 1x here, and I put the 8x, positive 8x here to make our first example easier to work with. So let's look at factoring the greatest common factor from the first group. So for 2x squared minus x, the greatest common factor is x. So x times 2x will give me 2x squared, and then x times 1 will give me x. So we have x times 2x minus 1. For the second factor here, I have plus, let's see, for 8 and 4, the greatest common factor is 4. So 4 times 2 is 8. Bring the x down. Bring the minus down. 4 times 1 is going to equal 4. So now I have x times 2x minus 1 plus 4 times 2x minus 1. Just like it was shown when we did factoring by grouping. You should have a common binomial in both of these to be able to factor out. So I'm going to factor out this binomial of 2x minus 1. And when we do so, we're going to have left remaining x plus 4. And if I just kind of push this together a little bit now, I can write this as 2x minus 1 times x plus 4. As I mentioned in a previous video, if you would like to kind of preserve this work without me crossing it out, please go ahead, stop the video at that critical point, and then write this part down again so that you can preserve the work in steps if that's something that you think will help you. So remember, you can stop the video from playing anytime you want. So please take advantage of that option. So in the factors of 2x minus 1 times x plus 4, we have now successfully factored the trinomial of 2x squared plus 7x minus 4 into these two binomials. So this is the technique for how we identify the coefficients, use our x box to identify the two numbers that multiply to a times c and that add to b, split up the middle term to come up with a polynomial of 4 terms that we apply factoring by grouping by to get the two binomial factors. So we're going to show some more examples of this to really reinforce the skill, as I know this is the hardest one for students to typically grasp. Let's go forward now to some of the questions. So let's take a look now at question 12. This is going to be 5x squared minus 19x minus 4. I'm looking ahead at this one, and I already kind of see where this is going, so I don't think it's going to be terribly difficult, but let's see. The value of a is going to equal 5, b is equal to negative 19, and c is equal to negative 4. So going to our x box on the side, we want two numbers, a times c, that multiply to negative 20, and we want the value of b that goes to negative 19. Now, we want two numbers that multiply to negative 20, and we want two numbers that add to negative 19. The difference of the numbers is almost as big as the product. So we're going to take a look at those combinations that we were neglecting in previous videos. For example, let's take a look at negative 1 times 20, and then 1 times negative 20. Well, negative 1 plus 20, that's going to give us 19. Right number, but wrong sign. So 1 plus a negative 20 gives us the negative 19 we're looking for. So for this problem here, we're looking at the two numbers, plus 1 and negative 20. These are the pair of numbers that we are going to use here to split up the middle term. Because of my knowledge of factoring, I'm going to be strategic about where I put these pair numbers. But in a couple more examples, we will begin to discuss what happens if we put the numbers in different places. What can that factoring look like? Because you need to understand that too. So I'm going to go ahead and I'm going to express negative 19x as negative 20x plus x. And this time I'm just going to write it as plus x. I don't need to put anything else than that. And let's see what happens with this now. So we'll have 5x squared minus 20x plus x minus 4. So I could have put the negative 20x over here and maybe over here and then move the x here. Well, there's going to be two issues with the factoring. Well, just ignore that. We'll go forward here. So I'm going to go ahead and split this up here, and I'm going to split this up and move it off to the side a little bit. So this will be 5x squared minus 20x. This is going to be plus x minus 4. Let's take a look at factoring the greatest common factor out of this first. For 5 and 20, the greatest common factor is 5. For x squared and x, it's x. So the greatest common factor from the first group is 5x. So 5x times x will give us 5x squared. 5x times 4 will give us 20x. So we have 5x times x minus 4. Now here's the second one. And there is an example I cite in the review video in section 6.1 where we have this similar issue. We look at x minus 4, and we look at this, there's nothing to factor. All we can do with this example is to simply on the outside write it, that factor, as a positive 1. Now, it doesn't change anything on the inside. We still leave the inside as x minus 4. So nothing changes here. But writing the plus 1 here is a very important step to obtaining the pair of binomial factors, which we'll see here in a moment. So now we've got, writing this again, 5x times x minus 4 plus 1 times x minus 4. Well, if I want to factor out the binomial factor that's in common, I'm going to factor out x minus 4. And in doing so, I'm going to be left with 5x plus 1. And this is why it's really important to put that plus 1 as a factor, because you need something to put here in order to get it back later if you were to multiply the binomial factors together. So we'll have x minus 4 times 5x plus 1. So let me go ahead and explain what I mean about having that plus 1 to get back the original problem. If these are the pair of binomial factors that are correct, if these are the two binomial factors, we should be able to multiply them to get 5x squared minus 19x minus 4. So we're going to do a check over here to see if this is correct. So we'll have x minus 4 times 5x plus 1. So x times 5x will be 5x squared. Negative 4 times 1 is going to be negative 4. Here, negative 4 times 5x will be negative 20x. X times 1 is going to be plus x. So negative 20 plus x is going to be negative 19x. So we have 5x squared minus 19x minus 4, which is what we obtained up here. Without that plus 1 being there, that we put as the factor here, we would have never been able to obtain this back. So we do have the correct factors for the trinomial given above with the a coefficient equal to 5. Let's take a look at a few more problems to further explore this option. Okay, so the next problem we're going to go ahead and look at is going to be question number 18. And this reads 15t squared plus 20t minus 75. When first looking at this problem, you may recognize it as one being, oh, this is really, these are really big numbers. These are going to be really awful if you have to multiply 15 times 75 to have to find products. That's not the case at all. Just like we looked at in the last examples in the last videos from section 6.2 when we're looking at certain types of factoring of trinomials, here too we may be expected to have to factor out the greatest common factor first. Factoring out the greatest common factor may not give us a coefficient equal to 5, but it will give us coefficients that are smaller and easier to work with. So, first in this question, we have to factor out the greatest common factor. And for 15, 20, and 75, that is going to be 5. So when we factor 5 out, this is going to get us 3t to the second plus 4t minus 15. So now that we factored out the greatest common factor of 5, we now have a trinomial that's going to be a little easier to factor. And I'm going to go ahead and write those a, b, and c coefficients down here, just so they're a little out of the way of the factoring we're going to need to do in a moment. So a coefficient is equal to 3, b is equal to 4, and c is equal to negative 15. So let's see how this is going to work. When we do our x box off to the side here, we're looking at a times c here. We're looking at b here. So a times c, or 3 times negative 15, is going to be negative 45. And then the value of b is going to be positive 4. So we're looking at two numbers that multiply to negative 45, but that add to positive 4. Remember, the only way we can get a negative product is by multiplying two numbers that have an opposite sign, but they have to have a difference of negative 4. So when looking at negative 45, we want the difference to these to be small, so 1 times 45 is probably not practical. Neither is 3 times 15. Those differences will be too large. If we were to take a look at, for example, negative 5 times 9 or 5 times negative 9, those will likely produce the results we're looking for. And as a matter of fact, if we take negative 5 and add that to 9, that's going to give us a difference of positive 4, which are exactly the combination of numbers we need. So we need a positive 9 and a negative 5 to not only give us a product of negative 45, but a sum of positive 4. So remember, we're not going to simply put these into binomial factors. We're now going to go ahead and we're going to replace the middle with these coefficients. So I'm going to go ahead and I'm going to put plus 9t here and then minus 5t here. So I'm rewriting the middle term 4t as 9t minus 5t, because 9t minus 5t is equal to 4t. It just enables us to rewrite the trinomial above as a polynomial with 4 terms that we can use factoring by grouping to factor. So now that we have 4 terms, we're going to split these up into 2 parts, and we're going to take a look at another aspect of factoring by grouping that can sometimes catch students off guard. So let's take a look at 3t squared. Watch out, I forgot to write that down, so make sure to indicate that, please. 3t squared plus 9t. And then the second group, sign is critical in this question. it's going to be negative 5t minus 15. So in this question, if I take a look at 3t squared plus 9t, my greatest common factor is going to be 3 and t. 3t times t will give me 3t squared. 3 times 3 will give me 9, so 3t times 3 will get me 9t. So this is factored. Taking a look at this part now, first thing we have to consider the fact is that this binomial we have in the second group begins with a negative. Therefore, we have to factor a negative out. And not only do we have to factor a negative out, we also have to factor the greatest common factor of 5 and 15, which is 5. If it helps, note that when you factor a negative out, just like we talked about in section 6.1, you have to change the sign of everything on the inside. So if it helps, put a plus sign there. You can rewrite it later differently if you want. But if it helps you to keep track of that so you don't bring a negative down, put your plus sign there. So 5 times 1 is 5. We're just going to go ahead and put a t here. 5 times 3 is 15. And in fact, yes, we've got t plus 3 as a common binomial factor here. So we're going to condense this a little bit. 3t times t plus 3 minus 5 times t plus 3, rewriting this t plus 3 without the plus here. We don't need to. It's easier to recognize that the t plus 3 are the same binomial factor. When I want to factor out this common binomial of t plus 3, it's easier to see that all remains behind is 3t minus 5. So let's consolidate this now to get t plus 3 times 3t minus 5 as the pair of binomial factors that we need from here. Except one little thing that we need to remember. Because we factored out 5 in the first step, we need to include this work in our final answer. It's easy to lose track of all this work along the way, but we need to be sure that we include this work, or we include that 5 as a factor of this as part of our final answer in the problem. Let's take a look at one more question. One more that contains some pretty hefty factoring that may be quite tricky for some students to follow, but is good reinforcements for some of the basic strategies here. So we're going to take a look at question 40. Question 40 reads as follows. This will be the last example we show for factoring by grouping in this video. So we have 50t to the third plus 115t plus 60t. Now, I am giving you an example where everything is positive. Am I not magnanimous? Am I not? All right. So, the first thing we need to do here is, again, factor out the greatest common factor. So, when we do this, for 50, 115, and 60, the greatest common factor is going to be 5. We also have a variable that's the greatest common factor, namely the lowest of these, which is t. So let's go through this one by one. 5 times 10 is 50. 5 times 23 is 115. 5 times 12 is 60. Then t times t to the second is t to the third. T times t is, that should be t to the second there. Okay, so let me just say for the record, that's supposed to be a t squared, so my apologies. That's how I got all this here. And that's how I factored out a t. So this should be a t squared here. And t times t is t squared. T times 1 is t. So now we have our factors. And we got a now equal to 10, b equal to 23, and c equal to 12. So these numbers are going to be pretty big, so we're going to have to look at this a little bit. So in our x box over to the side where we're looking at a times c, and we're looking at b, we need two numbers whose product is 120, and product of 120, and whose sum is 23. So we need two numbers whose product is 120, and whose sum is 23. So let's take a look to see what we can come up with. So for 120, well, we know 1 times 120 is 120. We know that 2 times 60 is 120. 3 times 40. We have 4 times 30. We have 5 times 24. We have, see, 6, 6, 6. I think 6 times 15. 6 times 15. No, 6 times 15 is 90. But 6 times 20 is 120. Is 8 times anything? I believe 8 times 15 is 120. And I believe also 10 times 12 is 120. Now, could you spit all these off the top of your head? Probably not. So even questions like this with the fine techniques I'm showing you can still be a little difficult when you're trying to find this correct combination. Since everything is positive here, and we're looking for 2 positive numbers here, we're just looking for the pair of numbers because these all multiply to 120. We look for the pair that adds to 23. And if you look here, 6 plus 20 is 26. That's too much. Like the porridge is too cold. 10 plus 12 is 22. Like the porridge is too hot. It's got to be in between 8 plus 15, which adds to 23, where the porridge is just right. So we're going to use plus 8, and we're going to use plus 15 here. And we're going to rewrite the center of plus 23 as the sum of plus 8t plus 15t. So I'm probably going to, for simplicity's sake, going to write the plus 15t over here, and then plus 8t here. If you were to reverse these, does it have an impact on the answer? It does not. I would encourage you, if you wanted to write this as 8t and 15t, go ahead and try it and see that the result will still be the same. So let me bring the 5t down, and then continue bringing this work down. I'm going to go ahead and I'm going to hold off on bringing this down further on my work to not complicate my work with factoring by grouping, but I know I'm going to have to bring it into my answer. So what I'm going to go ahead and do is I'm going to make a space for my answer below, and I'm going to put a 5t, and I know it's going to be times something. So I'm going to hold a space for it down there so I don't forget about it along the way. So I have 10t squared plus 15t, and I have plus 8t squared plus 12. Or 8t, not 8t squared, just 8t. So for 10t squared plus 15, this is going to be 5t. This will give me 2t plus 3. For plus 8t plus 12, this will give me plus 4 times 2t plus 3. So if I look to factor out the greatest common binomials out of this, is going to be 2t plus 3 times what? 5t plus 4. So consolidating this down to 2 binomials, we'll have 2t plus 3 times 5t plus 4, giving us our final answer of 2t plus 3 times 5t plus 4, and giving us our final factors for the trinomial that we have above. So to recap, as I've mentioned before many times, the first type of factor you always want to look for is the greatest common factor first. And we have a greatest common factor for a number and a variable. Once we do that, we identify the coefficients of A, B, and C. Bring it over here to find 2 numbers whose product is 120 and whose sum is 23. We identify that as 8 and 15, and we use these 2 numbers to split up the middle term. We split up 23p as a sum of 15t and 8t, and then we use it to execute factoring by grouping to get our final result. Any questions that you have on this technique, please bring to class, and be sure to look online for the review that should help support your learning.